which choice ranks these compounds from strongest to weakest acid? Here are a set of 3 compounds. One is a carboxylic acid. This is a carboxylic acid because of the functional group COOH. And this one right here is a sulfonic acid. Sulfonic acid. And it has the functional group SO3H. And this one right here is sulfinic acid. Sulfinic acid, 1 oxygen lesser than the sulfonic acid. And it has SO2H as the functional group. Okay, now between these 3, we needed to find out which one of those acids is going to be strong. And then from there, we are going to move on to the weakest acid. Okay, now the very important statement that's going to be helpful for us here is, we know that stronger the acid, weaker will be the conjugate base. Weaker will be the conjugate base. So this is the most important statement that will be useful for us in determining the strengths of these different acids. Okay, when you say weaker base, a weaker base is basically a stable base, which can be stabilized by electron delocalization such as resonance, or it could be because of the inductive electron withdrawal. Now let's arrange these compounds from strongest to weakest acid. I'm going to call these propyl groups as R in each one of them. Okay, and I'm going to pull these hydrogens and write the conjugate bases for these molecules. So for the first one, it's going to be a carboxylate ion. And this carboxylate ion is going to have another resonance contributor, another equally contributing resonance contributor, where I'm going to shift these electrons on here, and the electrons from the double bond is going to go on to oxygen. Okay, so that's going to result in another resonance contributor. Okay, I'm going to do the same thing for sulfonic acid. In the case of sulfonic acid, there are 3 oxygens. Okay, and therefore it can exist in 3 resonance contributors. Once I pull the hydrogen from there, so it's going to have a negative charge on oxygen, and that negative charge is going to be distributed between 3 oxygens. Okay, so I'm going to push these electrons in here. That's going to give me the second resonance contributor. And these electrons can hop in here to give me the third resonance contributor. And remember, in this case, there are 3 resonance contributors. And in this case, there are 2 resonance contributors. Now, let's take a look into the sulfinic acid. Okay, here again, if you look into this, if after you remove the hydrogen, and there are 2 oxygens where the negative charge can be distributed. So let's draw for sulfinic acid. For sulfinic acid, it's going to have 2 resonance contributors. We know that a conjugate base that has more number of equally contributing structures is going to be more stable. So in this case, sulfonate ion has 3 resonance contributors, whereas the carboxylate ion has only 2. And again, the sulfonic acid has got only 2 resonance contributors. And therefore, sulfonate ion is the one that's going to be more stable. And therefore, the acid that it has started with should be the strongest acid. Now we have to decide between carboxylic acid and sulfonic acid to be which one is the strongest, next strongest acid. Now in both of these, we know that there are 2 resonance contributors for the conjugate ion. And in the case of sulfonic acid, we can see that sulfur is a larger atom, and therefore it is better able to handle that negative charge if there is going to be anything that's going towards sulfur. So the next strongest acid would be sulfonic acid, and the weakest of all is going to be carboxylic acid. So the right option here is B.